The chemistry of fingerprints. The first thing we need to ask ourselves is, what is a fingerprint? Fingerprints are the patterns you see on your finger caused by ridges in the dermis, the bottom layer of your skin. These patterns are fully developed in humans just 7 months after conception. Fingerprints can be three-dimensional plastic on soft surfaces such as wax, soap, and paint. Not only do each and every one of us have our own individual traits and looks, but we have one thing that makes us completely unique and cannot be altered. These are our fingerprints. The three typical patterns are arches, found in 5% of the population, whorls, found in 35% of the population, and loops, found in 65% of the population. The idea of recording fingerprints started in Babylon and India for business transactions to trace the deal back to the original person by his or her fingerprints. Fingers were placed on tablets to create ridges from the skin unique to each person. Towards the late 1800s, Herschel began using ink to stamp fingerprints to discover criminal activity.
ALS, or alternative light source, is becoming a more common place for investigators to examine likely surfaces, such as doorknobs, computers, windows, railings, etc., with an alternative light source. There are laser or LED devices that emit a particular wavelength or spectrum of light. Some have different filters to provide a variety that can be photographed or further processed with powders, dyes, and stains. An investigator may use a blue light with an orange filter to find latent prints on desks, chairs, computer, or other equipment. Like fingerprint powders, chemical processing can reduce the investigator's ability to perform other techniques that could reveal valuable information. Any non-destructive investigations are performed before the evidence is treated with chemicals. For example, a ransom or holdup note will be examined by a questioned documents expert before being treated with ninhydrin. Since some formulations of ninhydrin will cause the inks to run, this destroys the writing. This is called fingerprint analysis.
Investigators often perform cyanoacrylate, also known as superglue processing, of a surface before applying powders or dye stains. This process, typically performed on a solid surface, involves exposing the objects to cyanoacrylate fumes. The fumes will adhere to any prints present on the object, allowing them to be viewed with a white light source.
Fingerprints identified at crime scenes fall into three categories: patent, latent, and impressed. Patent fingerprints are clearly visible to the naked eye. They are made because the individual has had their fingers in some sort of liquid or powder, such as blood, ink, or even oil. A close-up photograph is often all that is necessary to record it. Latent are not visible to the naked eye. They can be made visible/identifiable by introducing them to a powder or chemical agent. And lastly, impressed have been made in soft material or tissue by pressing down with the finger or hand. These can also be photographed, but only in certain circumstances where molds are made.
A new technique developed by R. Graham Cooks allows for chemical analysis of fingerprints. This technique is called desorption electrospray ionization, or DESI for short. DESI can reveal drugs, explosives, and other materials the person might have handled. It can even be used when fingerprints are laid down on one another by several different people. Each person's print has a unique chemical makeup, and it is this difference that allows examiners to separate the piled up prints from one another.